In this video, we're going to talk about topic 1.3, or elemental composition of pure substances. So the topic says to explain the quantitative relationship between the elemental composition by mass and the empirical formula of a pure substance. So a pure substance, as a reminder, can be a single element or it can be a compound, covalent or ionic. So we use chemical formulas to talk about our pure substances. Our chemical formulas are governed by the law of definite proportions, which says that a given compound will always have that exact same proportion of elements by mass. So that means water is always going to have 2 hydrogens to 1 oxygen. If it doesn't, it's not water. We can use this law of definite proportions and we can use mass data to determine formulas. Now, there are 2 types of chemical formulas. The first is an empirical formula. The empirical formula is simply the lowest number whole ratio, molar ratio of the elements in the compound. It is not necessarily the actual ratios of the elements. So it's just the lowest number. You can think of it almost like a fraction. It's the most reduced form. The molecular formula, on the other hand, is the exact number. So it is not the most reduced form. Molecular formulas and empirical formulas can be the same. They can also be different. Okay, so an empirical formula can be the most reduced form of a molecular formula. To get from an empirical to a molecular formula, you can use the molar mass to figure out how much more massive the actual compound is compared to what the mass is based on the empirical formula. If the given molar mass, if the known molar mass of your compound is 3 times the molar mass of using the empirical formula, you know that your ratios are 3 times the empirical formula. Now, to get the empirical formula, you're most often going to be given either masses of the different elements or percentages. If you're given percentages, you can just assume that it's out of 100 grams. So then your percentage and your mass are the same thing. So since it's lowest whole number molar ratios, you first need to convert your mass into grams. It's already in grams. You need to convert it to moles. Okay, so you're going to convert grams into moles just like we would with any other gram to mole type problem. And then you're going to look at the lowest ratio. Okay, you can't just necessarily round all of these ratios. Sometimes if you end up with a ratio of 1.5 or 1.5 to 1, that's really a ratio of 3 to 2. So you need to use some specific reasoning when you look at these ratios to determine what is a reasonable ratio between the elements. Okay, once you have that lowest whole number molar ratio, that's your chemical formula. Okay, so those ratios, those numbers tell you how many of each of those elements are in that compound. Now, to get to the molecular formula, you'd have to know the molar mass of your actual compound. And like I said earlier, if you know the molar mass and you know the mass based on the empirical formula, you just figure out how much bigger the molar mass is of the actual compound compared to the empirical. If it's twice, you know you have to double all of your number ratios. If it's 3 times, you know you have to multiply each of them by 3, so on and so forth. So that's how you can get from your empirical to your molecular formula. All of these are based on the mass, and the key here is that they have to be whole number ratios. The empirical is the lowest whole number ratio. The molecular tells you the exact number. The molecular can always be reduced to the empirical unless they happen to be the same.